Hello, DjangoCon Europe. Welcome to my presentation, GraphQL-first Django. My name is Marcin Gębala, and I'm really excited to be speaker at this year's DjangoCon. I wish we were seeing each other in Porto now, which is obviously not possible, but it's still really amazing that organizers were able to run this conference online. So this is really, really amazing. So first, I'd like to tell you a few words about me and what I do. So I'm a lead developer at Saleor Commerce, where I'm responsible for leading the backend team behind the Saleor GraphQL API. I'm also a Python Django developer. I've been using those technologies for 5 or 6 years now, and I'm also a huge enthusiast of GraphQL. I've been working with this technology for about 3 years now, together with Django. So I'm based in Wrocław in Poland. Wrocław is a beautiful city in Western Poland. So whenever you have a chance to visit our country, make sure to put it on your list. And very quickly, a few words about Saleor. So Saleor is an open source headless e-commerce platform. So e-commerce platform means that you can use this software to build and run online stores. Headless means that frontend and backend are decoupled in this application. So it's not a monolith app, but frontend are separate apps here, which allows for really great customization and flexibility in how you use this API. So at the heart of the platform, there is this GraphQL API. It's built with Django and Graphene. It's pretty large. It has over 350 operations now. And we have those two front-end apps. You can see the storefront on the right. So the storefront is a template of the online store that your customers would use to buy products. And there is also the dashboard application for store owners. So both of those apps are single-page apps built with TypeScript and React, and they are using our GraphQL API. So if you are interested, make sure to check it out at saleor.io or find us on GitHub, because all of that is open source. So what is GraphQL? GraphQL is an open source data query and manipulation language for APIs. That's the official definition. I would also add to that that GraphQL is API language for single page apps, because that's its main purpose, and that's where it really shines. So let's take a look at GraphQL and how it looks like. So on this slide, you can see example from Saleor GraphQL API. This is a interactive explorer. Almost every framework for building GraphQL servers provide this kind of explorer. So on the left, we have the query. This is a query where we are getting products from the API. And for each product, we are getting some fields like name, description, category, and variants, for example. So as you can see, this is a nested structure. And on the right, we have the response. So this is a JSON response. And what is important here, we are getting only data that we have asked in the query. So this is how it looks like very quickly. And now, what are the main features of GraphQL? So first of all, we are fetching only data that is needed, and it is the client that decides what data to fetch. So this is very big difference when you compare GraphQL to REST. And the idea behind that is to limit amounts of data transferred from server to the client. We have 3 types of operations in GraphQL. We have queries, which you already saw on the example before. We also have mutations and subscriptions. So mutations are equivalent of post, put, or patch requests in REST APIs. So we use them to change data on the server, to create objects, update them, or delete them. We also have subscriptions, and subscriptions are real-time queries. So we can use them to fetch data in real time. Of course, they require WebSockets, so our server needs to support WebSocket connection in order to handle those subscriptions. In GraphQL, we are combining multiple resources in a single request. So it's not like in REST where we have specific endpoints for different types of resources. In GraphQL, there is only one endpoint. And as you saw on this example before, we have this nesting, and we can use this nesting to traverse relations between our types, between our models, and we can combine those types in one request. So the idea here is that a single page app can only send one request and decide what data it needs to render a particular view, and it doesn't have to hit multiple endpoints. So of course, there is less traffic between client app and the server. We also have strong typing, which means that every field in the API or every argument in a mutation has its own type. This gives us static error checking when we write those queries in an editor, which is really nice. And this all leads to amazing developer experience, which is also one of the most important ideas in the GraphQL ecosystem. So we have those interactive IDEs to build our queries. We have API mocking. We also have code generation. And this is a very powerful feature in the frontend. Because, for example, if you are using TypeScript, and if you have a really large single page app, then you should probably use TypeScript. So when you do that, you can generate your TypeScript types from the GraphQL schema. So whenever the schema changes, whenever developers backend team adds a new field, frontend team can just regenerate those types, and they will instantly know that there is a new field that they need to handle. So very quickly, let's look at the schema. So schema is a definition of the GraphQL API. You can think of it as a contract between frontend and backend. So here, in this very simple example, we have those two special types, type query and type mutation. So these are our queries that we have in our API, and here is example mutation, and this is the signature. This is input data that we need to provide in order to create the product, and here we have the response from the mutation. As you can see here, we are defining our own type. We can use those built-in types like string, for example, to create our more complex types. And here we define the input. So in GraphQL, we have two approaches, schema first and code first. Schema first means that we first create those schemas, and then we build codes in our programming language to fulfill these schemas. In code first approach, on the other hand, we first build our code, our classes to represent the schema, and then the schema is generated from the code. So now I'd like to talk about this GraphQL-first Django architecture. And the reason why I'm talking about this kind of architecture is that our product, Saleor, is basically using this architecture. Fun fact is that Saleor was in the past a typical Django application with templates and views. But after we've migrated to this headless architecture, Django is only used as the GraphQL server. So now I'd like to tell you a few aspects of this architecture. So we're going to use Graphene framework here. So Graphene is a high-level framework for building GraphQL APIs in Python. You can use it standalone with Python, but it has very rich ecosystem of libraries and integrations with other frameworks such as Django or Flask. Actually, from all the GraphQL libraries in Python, I think Graphene has the best toolset for Django. So also that's the reason why we are using it here. And what is important here is that Graphene is also code-first framework, which means that we are building Python classes and Python functions, and the GraphQL schema, this contract, is generated from our Python code. So let's look at the project structure in this GraphQL-first Django architecture. As you can see on the right, there is a simple example of GraphQL project that I was using while working on this presentation. So maybe let's start with those files that we have in the root directory. As you can see, this is pretty standard what we have in Django. So we have settings spy for configuration, and we have URL spy. We also have WSGPy and ASCII-py, so that means that we are using the newest Django because of this file. So this is pretty standard. What is more interesting is the architecture of a single application that we have in our Django project. So in this example, I have this products app. So what do we have here? Models are pretty obvious. This is as in every Django application. In this file, we define our models. So in this case, we will have a product model, for example, and a category model. So this is pretty obvious. But what is a bit different are those other files. So we have types file. So here we define mappings from our models to GraphQL types. We will see that in a moment, how it looks like. Then we have mutations file, where we define those operations to change data on the server for this particular application. So here we would have operations for creating products, updating or deleting them. We also have data loaders file. So data loaders are a way to efficiently run database queries in Graphene. So we're going to talk about that later as well. And lastly, there is schema py file. So every app in this architecture would have this schema py file, which simply imports all the types, all mutations, and exports this schema per particular application. And then we also have this global, this root schema file, which imports all the app-specific schemas. So here we merge our schemas and expose that to the GraphQL view. So this is how the project structure looks like. Now let's look at our URLs. As I said before, in GraphQL, there is only one endpoint. So in our URLs, when we are starting with our application, usually we will have only this one URL. So there is this path GraphQL. We have this GraphQL view, which is provided by Graphene Django library. And that's basically it for the URL configuration. When we hit this endpoint with a GET request in the browser, then we would see this interactive explorer that would allow us to play with the API. When we send a POST request instead, the API, this endpoint would return the JSON data for particular query that we send in the request body. So this is how we communicate with the API using POST request. So now let's look at types. As I said, in our sample application, we have the product app, and we have also the product model. So now we want to expose that model in the API somehow. So how can we do that? First solution would be to write all of the type fields by hand, but Graphene Django provides us with this very nice class called Django object type. So we basically create our type as a new class that inherits from Django object type. And now let's look at this class meta here. You are probably very familiar with this concept because that's also what we do in Django. We declare that this Django object type should use the product model from our products application. Then we specify what fields we want to include in the type. This is useful because we don't want to expose all fields automatically. We want to be sure which fields are exposed in the type. So that's why we use these only fields here. And that's basically it for Graphene to create a GraphQL type based on our model. If we wanted to add custom fields to our type, we can easily do that as well. And we do that in a declarative manner. So this is an example of custom field. So we declare those fields here at this level. So it's very similar to declaring model fields. And for each field in our type, we also need to create a resolver. So let's look at this method here. Resolve price is a resolver function, and it will be called by Graphene whenever it finds this field in the schema. So basically, resolver tells the framework how to return data for our field. Root is instance of our model here. So using this, we get the price field from the instance, plus we get the currency from settings, and we use that to return the money type, which represents the price of a product. So now, how do we define queries? We define queries in the schema py file. And in this example, we have only one query. So we do that very similarly. So this is a declarative style. Again, something similar to what you already saw, something similar to what we do with models. We declare that there is one query called products. It is a list of product types, as simple as that. And for that field, we also need to define a resolver function. So in this case, we define the resolve products function. And as you can see, we are using Django ORM to return all products from the database. So this is a very simple example. Of course, if you wanted to extend this query with some arguments, we could easily do that by specifying those arguments here. So we could use that pattern to, for example, support filtering, sorting, or pagination. And if we define an argument here, it would be available here in the resolver. So now let's talk about mutations. Mutations seem a bit more complex at first glance. So let's talk how we implement them. So basically, we use this graphene mutation class for that. And every mutation represents a single operation. For example, this one is used to create products. So every mutation is implemented as a class. So let's look what is going on here. At the top of this implementation, we define what would be the output of the mutation. So in our case, we want to return a new product instance and a list of errors that may occur during execution of the mutation. Then in the class arguments, we define the input. So this is data that we need to provide in order to create the product. So we saw that already on the schema a few slides before. I've skipped implementation of this product create input because it's very similar to what we have here. It's just a simple class with declarative fields that match with our fields in our model. What is most important here is this mutate function. So this is basically the resolver of that mutation. So what we want to do here is to get the input data and create a new product instance. So we are doing that in this first line. Input represents the incoming data. We populate our newly created instance with this data. Then we can run some basic validation. So in this simple example, I'm using full clean method from Django models. And of course, if there are any errors, like for example, a field was required but was not provided in the input, I would get a validation error here. So here we are catching all those validation errors, converting them to, with those small utility function, to a format that will match with the format of this output field. And if everything is fine, then we just save the newly created instance and return that to the API user. So this is how we define mutations. If you look at this code, you may think that if you have a lot of mutations to write, then probably it would be nice to use some abstractions. For example, to have the common logic for validation. So if I had a few mutations like this, I would like to have this code separated, moved to some utility function or some mixin, for example. This can be easily achieved because those mutations are classes. So we can implement those abstractions similarly as we do with Django class-based views, right? So Graphene provides us with one abstraction that can be useful if you are using Django forms. So with those, so there are form-based mutations, and what they do is they take a form. So let's assume that we have a model form called product form, which we can use to create new products. So if we use this Django model form mutation, which is provided by Graphene Django, we could say here that this mutation should use this form. And based on that, this mutation would generate for us input for that mutation automatically from that form, entire logic that would be delegated to the form, and the output that would be the new product instance or errors, those validation errors that could happen during the execution of that mutation. So this is very useful abstraction if you want to like forms, which are really nice tool provided by Django. Also, you can benefit from forms to, for example, encapsulate the validation logic in those forms. So this is a very helpful abstraction if you need to build a lot of mutations like this. So now let's talk about authentication. Most apps require some authentication ways, and because GraphQL is designed for single page apps, In single page apps, we most often use JSON Web Tokens. If we wanted to support JSON Web Tokens in our Django application, our Django GraphQL-first Django app, we need to use this library called Django GraphQL JWT. So JSON Web Tokens are not provided by default. Support for that is not provided by default in Graph in Django. We need to use this library. And when we install this library, we would have, for example, this mutation in our API. This is called token create. And as you can see, this mutation accepts user credentials. And when user pass those credentials and they are correct, we can ask for the access token or refresh token, for example. We can extend this mutation as well to return the user. So if we want to log them in our single page app and immediately render the email or avatar, we can ask for this data here. So once we have the token, access token, we are using this authorization header to pass this token and authenticate subsequent requests. Of course, this library also provides a middleware so that our app understands how to parse those headers and how to get the user from those tokens. We can also use this library to restrict access to particular fields in our API. So let's look at this example. We have, again, our product type, but in this case, we also have a revenue field. So this field should be restricted only to admin users with a specific permission. In this case, it's product, manage products permission. We are using here standard Django permissions framework for those permissions. So this library gives us the permission required decorator, and we can use it to decorate our resolvers. So if we add this decorator here, when the token is passed to the API, Graphene will check if the user has this permission and will only return data if they have those permissions. So another aspect of GraphQL-first Django is database performance. So you probably heard about this N+1 problem. This is a problem that we can have in classic Django, for example, in templates, when there is a relationship between our data, like one-to-many, for example. So in our case, we have a product. Each product can have a category, and a category can have multiple products. So there is this many-to-one relationship between those models. So what we do in Django views, we use select related or prefetch related to avoid duplicated queries, right? But this is not necessarily the best way in GraphQL, because in GraphQL, as you remember, it is the client that decides what data to fetch. So we might get a query that only asks for product name, but we also might get a query that asks for those categories. And we only want to run those performance improvements, so those select related methods, when user actually asked for those categories. We don't want to run them always. So we need some way to do that dynamically. We achieve that by using data loaders. So data loaders are a concept which is used in many GraphQL frameworks. It originates in the first implementation of GraphQL that was built in JavaScript. So maybe let's first look at how we use them, and then I'll tell you how it works. So again, we have our product type. We want to return a category for this product. So without any optimization, we would simply, in this resolver, we would simply do root.category, where root is our product instance, which would, of course, without any prefetching, that would run another database query. With data loaders, we use this category ID. So in our instance, we know what is the ID of the related category without fetching it from the separate table. Then we pass this ID to the data loader with the load function. And that's it. That's what we do in those resolvers. And now, here's the data loader implementation. So whenever, so when Graphene processes this query, it will look all occur in the query. it will gather all the keys that we have passed here, so database IDs. And because it returns a promise, it won't immediately return the category object. Instead, it will gather all of those keys. And as you can see here, we pass those keys to a ORM method here to get this data in one query. So because of those promises, Graphene will only run that at the end of the processing that GraphQL query. So this is something new to Django developers because promises are not concept used in Python. In the next version of Graphene and hopefully in the next versions of Django, we will be able to use async await syntax here in the future once asynchronous execution is supported in Django and database access as well. So this is synchronous code. It's using those promises which are shipped with a Graphene library. It's a little bit hard to understand at first, but it's relatively easy to use once you know how to use them. To inspect how many database queries we are actually performing, we can use the good old Django debug toolbar. So as you can see here, we are running our Explorer, performing some mutations, and here we can see that there are 26 queries in the background. We additionally need to install this Django GraphQL debug toolbar because otherwise this debug toolbar doesn't work with those interactive explorers. And I also wanted to tell you a bit about testing. So we need to make sure that we have all of our operations are tested. So in Saleor and in those simple examples that I'm showing here, we are using PyTest. And how can we test our API with PyTest? So this is a definition of the query. In this case, this is a mutation that we want to test. It accepts some variables. And it's just a multi-line string in Python. So then we use this query here. Here we define our variables for the test. And there is a little bit modified API client, which has the PostGraphQL method. This is something that we built in our system. It's very simple implementation of the classic PyTest client that allows you to query your server. And we just pass this query here and check if we get data that we expected. As a bonus, I wanted to show you real-time queries. So these are those subscriptions that we have in GraphQL. As you can see on this example, we are getting some data in real time. In the query here, we are using the keyword subscription. And here we are getting feed of some messages. Can we implement those subscriptions in Django? Unfortunately, the answer for now is that Graphene Django doesn't support subscriptions out of the box. And the reason is that there is no ASCII view or consumer to process WebSocket requests. So there is ongoing work on adding support for subscriptions. So we may have that in the future. For now, we can use third-party libraries. So it is possible to add subscriptions to Django, but we need to use Django channels. So those two libraries rely on channels. To be honest, I haven't used them much. I know they are, you can implement subscriptions with them, but I would say it's still something a little bit experimental. So I think we need to wait until async support is provided by Django and Graphene. So, is Django a good choice for a GraphQL server? So first of all, for me, Django is productivity. I love how Django provides very useful tools like migrations framework, which is really amazing, ORM, which is really easy to use and very powerful, and all of the utilities that you have in Django. So I always thought that with Django, you can build stuff very fast. And if you use that with Graphene and those code-first approach when you generate types from models, I think that you can progress very fast with building your application. So I think that's very, very big advantage of this stack. If you are using Graphene, you will see a lot of familiar concepts such as object types, form-based mutations, and all of them are using this declarative style, which is very familiar to Django developers because this is how we use models, for example. What is also important here is that it's relatively easy to add GraphQL API to an existing Django app. So if you already have a Django app, it's pretty easy to write those object types to map your models to a query. And if you want to experiment with the GraphQL API, it's relatively easy to do with Django and Graphene. And as an example, you may want to take a look at Saleor GraphQL API, which is entirely open source, and you can find that on GitHub. If you want to see how we implemented some particular features, you can look at the source code. This project is 3 years old now, this GraphQL API in Saleor, and it's used in production. Also, there are some cons here. So first of all, fully fledged server requires many additional libraries, which are not always well maintained. So as you saw, we need to use additional library for JSON Web Tokens. There are also libraries for file upload, for some abstractions and utilities. So there are many libraries that are in this ecosystem, and some of them are not really well, in my opinion. Some of them are rather small packages. So if you want to use that in production, there is always this small risk that whenever a new version of Graphene comes out, some packages may be behind. So there is always this risk. So it's not like in Django REST framework where a lot of functionality is provided by the framework itself. Another disadvantage of Graphene and this stack is that there is not many good learning resources. Unfortunately, documentation of Graphene is not the best one. When you stumble upon some troubles, some harder problems, you often need to read the source code, which is also not the easiest one to read, the source code of Graphene, I mean. So definitely, yeah, you need to spend some time if you have some difficult problems with implementation. Also, the roadmap of Graphene is a little bit uncertain. There is new version coming, but I'm not sure if there is any release date, and I'm not sure if all of the features will be supported. There are some features missing in the in Graphene that are available in other implementations of GraphQL servers in other languages. So do we have any other options? Yes, there are other libraries. For example, Ariadne. This is a completely different philosophy because Ariadne is a schema-first library. So in this library, we first build the schema, then we build the Python functions to fulfill the schema. But it's really useful when you want to use subscriptions because it's fully asynchronous. It has first-class support for those subscriptions. It provides WSGI and ASCII views for Django. So there are no those mappings from models to types, for example. You need to build them by hand, but still you can use that with Django as well. What is very nice about this package is that it has very active community on Spectrum. Actually, currently, this one is the second most popular after Graphene when you look at GitHub stars. So that's all I've got for you. I hope you enjoyed the presentation. If you have any questions, I'll be available on Slack. You can also, I think we have still some time for questions now. You can also find me on Twitter or email me. Thanks a lot.
Big problem for me. Oh. And the one big problem I had was like some of my logic was in separate functions because I wanted so my business logic to be somewhere else, not in the objects. And it made it very difficult to debug because Graphene just doesn't let the error to be thrown. So it never gave me a 500, for example. So it captures the errors and I get the result saying there's an error in that line, but it doesn't even say which file it is in. So it says, well, there's an error in line 10, and I'm okay, cool, but in line 10 of like which file. So it made me really hard to debug because like there's a type error, but well, where in my logic there's a type error. So I don't know if I was just doing something wrong or if there's a solution for that.
Actually, So I think it's a problem in Graphene in the default implementation of the GraphQL view. But what we did in our project that we use in production, we created our own version of that view, basically overridden it. And I'm just trying to look at where do we have it in the code, but there is a way to write your own error handler or something like that. So basically the default one, as you say, catch all the errors, and it's not very useful. I need to find that in the code. Give me 1 second, but I'm pretty sure that we needed to customize it a little bit. Actually, we are using Graphene, but we have a lot of small customizations here and there, and this is one example to handle errors. So yeah, I agree. That's in the default implementation of Graphene. It's not the best one. Actually, wait a second. I can probably send you a link to. Can I share some links in this call? I don't know.
There's a chat here,
Mm-hmm.
but I think Slack would work too.
Yeah. So maybe I'll share that on Slack in a moment, but if I find it quickly on GitHub, GraphQL view, because we do have that in our code, which is on GitHub entirely, and maybe that would help. Yeah, I get it. Copy permalink. So where is the chat here? I think I'll send the link on Slack because I cannot find.
Well, no worry. I can ping you later. Just
Yeah, I have it.
The chat link is there in the left corner.
Yeah.
Yeah.
So here is the link. You can take a look at what we are doing in our project. So this is basically our own version of GraphQL view. It's like extended version of what the default one does. And over there we have the, for example, error handling. We have some additional features, like for example, for monitoring our API, we are using open tracing, which is a nice protocol for monitoring your apps. And we do have those open tracing tags over there. So whenever a GraphQL request is starting, we can mark where it starts and when it ends. So then we can measure performance of that query, for example. So we can look at those examples, what we've implemented there. So as I said, it's a little bit a customized version of Graphene.
Cool.
Any other questions?
Yeah, probably I will start. So hey, Marcin, can you hear me?
Yes.
Cool. Yeah. So first of all, thank you for the amazing speech. It was really nice to hear about graphical implementations. So yeah, we've been following your Saleor implementation of GraphQL for maybe over a year, since we're using that at Corner Case Technologies for almost a year already. But we also had a lot of cons and pros when compared to the REST framework. But probably what was always a question for me from the Saleor implementation, do you have any plans on maybe providing your custom implementations, abstractions, file uploaders, and so on, which maybe on a development phase might require a lot of time to find a proper solution? But maybe did you had any plans, on providing that as a library, as a maybe some implementation, which, for example, would be used by your project, but also available for public access and public implementations?
Yes, we had some discussions about that. Unfortunately, because the team behind Saleor is not that big, in fact, we are just a bunch of developers, and we were always so busy with developing stuff at Saleor that maybe we had no time to actually provide a pull request to Graphene, but probably that would be the best idea. At some point, I was a bit skeptical about Graphene because this project was maintained by one person at some point, and then this person stopped maintaining it, and there was huge discussion whether it will be maintained anymore. And now there is a group of people, and I remember that there was this transition between those maintainers, and at that time we had many questions about Graphene. We were opening some issues on GitHub, and there were like sometimes without any response. And I saw also that some pull requests were, they were not merging many pull requests from the community. So, it like I felt that it's not really well maintained at that point. And now maybe when the Graphene version 3 comes out, maybe it would be easier then. So definitely that would be useful for the community, because Graphene is still the most popular GraphQL framework for Python. So for example, we could abstract away our model mutation implementation. So we have our own abstraction to build mutations from models, and it's also very customized for our needs, and it would probably require some time to make it more universal.
Sure.
But yeah, I need to think about that and write that down, because it's nice that you are saying that you're looking at Saleor as an example, because when we started building our API, I couldn't find any examples of a GraphQL API in Graphene that would be, let's say, production ready. Only what I could find was some sample projects. So yeah, maybe that would be a nice inspiration for me to actually start thinking about abstracting some things away, because we are gonna use Graphene probably for some time. We are not thinking about migrating to something else, although the Ariadne library that I presented